Hi, good morning, everyone, and welcome from a very wet and rainy Seattle, which is probably not a surprise to any of you that have been here. So today we're going to go through the OWASP Top 10 project. Some of you may have seen this presentation before, but you will see by the shiny little star on the screen, it's now new and improved, because since I gave this last, they changed the top 10 list, which was great fun this weekend when I realized I had to write more demos. So there we have it. So my name is Barry Dorrans. I work for the Microsoft Information Security Tools team. That means I write things that basically annoy everyone else in Microsoft because it stops them doing what they want in our network. I'm also responsible for anti-XSS and the security runtime engine, so that will get a mention later because that helps me come review time. I've pimped it out, therefore I can tick that box out. So, first off, what is OWASP? Well, OWASP is basically an enormous wiki plus a bunch of local meetings that are free to attend, and it's full of people who are thinking about vulnerabilities, but more importantly, trying to share information on how to stop them, because thinking about them is all very well, but if you don't actually look at the platforms underneath and actually come up with demonstrations on how you can protect yourself, then it's just a thought exercise. So every few years they produce the top 10 web vulnerabilities for the previous year, which gives people an idea of what they should be protecting against, hopefully. So a couple of things. Please, when you're looking at these things and you see how the vulnerabilities work, please don't try them at home or at work or on any website that you do not own. If you want to go try them against your work's website, then go find your network admin first, get permission, get it in writing, because if you break the work website, you may not be the world's most popular person. The vulnerabilities that we're going to go through today are not just for ASP.NET, they're pretty much for everything out there. They're all pretty generic. They'll work on PHP, they'll work on Ruby, they'll work on Java. So don't just think that this is a problem with ASP.NET. This is a problem with web applications as a whole. Now, I realize that sometimes when I go through these things, people will look at what I'm doing and go, oh, I'm a bit worried now and I need to go check my work website or my own website. And it's sometimes not one of the things that you want to question about. We're a little bit more isolated here in that none of us can see each other, which is very, very strange, to be perfectly honest. So you can ask questions reasonably anonymously within the webinar software. If you still don't feel comfortable with that, well, you can email me at home, and I'll do my best to address your concerns. So, number 10 in the updated OWASP Top 10 is unvalidated redirects and forwards. Now, this one's quite interesting, because this one, web forms is protected by default, but MVC version 1 and MVC version 2 is not. MVC 3 is. So I'm going to quickly demonstrate it. And we'll clear this down. So hopefully you should now be seeing IE on your screen. If not, there's not a lot I can do, but you can complain about it in chat and maybe it'll get there eventually. So if I click on my link, it goes to an MVC application. Now this is an MVC 1 application because I'm running everything in Visual Studio 2008 because, well, you know what, not everyone's upgraded to 2010. So here we have standard, straight out of the box MVC login screen. You should all be familiar with this, but if you look up in the URL bar, you will see that I've tagged a parameter onto the end. And the parameter on the end is probably familiar to those of you that have had to deal with forms authentication, the return URL parameter. Now what this controls is where, after authentication, your browser is redirected to. And normally that's going to be somewhere on your website. But you can see here that being a naughty boy, what I've done is I've specified a return URL to a deeply offensive website on the internet, kittyperry.com, because no one really wants to go there. So if I log in, if I can remember what I set my test password up as, it will eventually process after it spins up SQL Express. And it wasn't that password. Oh dear, we're off to a good start. None of my standard ones. All right, let's register somebody new. Ah, that'll be why. I should have let Internet Explorer remember things. So you can see I've had a successful login, and it's redirected me to kittyperry.com, which, you know, whilst in itself is deeply amusing, you may think is not much of a vulnerability. However, what if it redirected to a website that basically has another login screen that looks the same as your application? Users tend not to check URL bars. They don't even check HTTPS certificates. So they will just see a login screen. It could have the red text that says, sorry, your password was incorrect. So they'll just try and log in again, as you saw me try to do because I'm forgetful. And then someone could capture the username and password, redirect back to your website again, and then they'll just see yet another login screen. They'll think they've got their password wrong twice. They'll type it in again, and lo and behold, they're in your application. So what's happened is the bad site has captured the username and password, and now your user's account details are compromised. So this is kind of an example of phishing via this open unchecked redirect. So if I bring up Visual Studio and I scroll down and I go to my account controller, you will see that we've just got Mr. Standard account controller here. And we've got validate logon, and so on and so forth. So what you need to do, and this is documented in John Galloway's blog, is you need to check that you have a local URL. And this piece of code here is actually lifted out of the web forms part of the .NET framework. And then you check whether something is a local URL, and it will redirect only if it's a local URL. So if I comment out the redirect code here, here is my isLocal URL code. So it'll redirect only if it's a local URL, and if it isn't, it'll go back to the home page. So if I compile this up and go back to my compromised page, you can see I still have my return URL. We'll go way, way back. Start again from scratch. I still have my redirect to Katy Perry, and I've forgotten my password already. And you will see now, instead of redirecting to kittyperry.com, because we have this code in to check whether something is a local URL or not, that check has failed, so it's just going to redirect back to the home page. So hopefully that's clear for everyone. Here you can see that I've put in the PowerPoint slides the URL to John Galloway's blog entry, so you'll be able to just basically cut and paste the code from there. So do we have any questions on that? Because after each one of these, I'm probably going to stop and ask for questions, because it's easier to address them as I go through each point. Anything? Nothing?
I don't see anything yet. Anything yet?
Are any of you alive? Awake? Because I know some people were who put their hand up. That's very funny. I know some people were waking up from Australia. Ah, hello Troy, I can see you. So I don't expect all of you to be awake. So I'm going to assume that this is then clear. So if you're running MVC 1 or 2, please go to John Galloway's blog and basically cut and paste in the is local URL code and change your authorization control. So next one. Insufficient transport layer protection. Basically what this boils down to is you should be using SSL as much as possible. Now, the old excuse for not using SSL was, oh, it's terribly, terribly expensive. But you can get an SSL certificate now for $20. $20 isn't that expensive. The other excuse that was used was that it slows things down. And actually, yes, that's true. There is a little bit of overhead that happens at the beginning of an HTTPS handshake. But after that, it's pretty much the same. So there's not really any excuse not to use SSL. So that's fine for your public-facing side of things. Any of you that have dealt with credit card information or PCI compliance will know that sticking SSL on your front-end web server is not enough. The PCI folks demand that any communication between your web server and anything else is encrypted. So if you're talking to SQL Server, you can configure SQL Server to use SSL. If you're talking to a WCF service, well, you can attach an SSL certificate to that. And that's all fine and dandy, but sometimes you have to talk to machines which can't support SSL, to services that don't support SSL. In this scenario, you have IPsec IP security, and what that does is that will allow you to encrypt at a transport layer. So that means basically you don't have to do anything different within your code. The networking stack takes care of the encryption for you. There's one more thing, which are replay attacks. Now, SSL takes care of this, but sometimes, for example, if you're doing WCF, if you're using SAML tokens, for example, you will find that each of the communication messages has a timestamp in it, or some sort of identifier that is unique. And what you should be doing is you should be looking for this unique identifier, saving it, and then if something else comes down with the same unique identifier, you should be rejecting that message. So you'll find things like WIF and so on and so forth will have this sort of unique identifier, but they don't do this for you. You need to write this code yourself because it's very architecture specific. You know, if you're taking SAML tokens down, well, you know, we don't know what sort of devices you have on the other side, whether you're going to store things in memory, whether you're going to store things in a SQL server, and so on and so forth. So every time you get one of those sorts of requests coming in, you should be logging it to whatever your architecture supports. If you're running Windows Server 2003 onwards, you can set up your own certificate authority, which is great for testing because you can just issue a bunch of certificates yourself as if you were VeriSign. And you'll find that becomes incredibly handy when you're using WCF services because WCF will take a look at a certificate that it's attaching to or a certificate it's attaching from, and it will go through what is called the certificate revocation list. So a certificate revocation list basically is something that the CA hosts, and it says, well, basically all these certificates that I've issued, this one is bad, that one got compromised, and so on and so forth. This is something that you can't do with self-generated certs, so it's probably a good idea just to keep a test CA on a Windows 2008 VM or a Windows 2003 VM and use certificates from the CA because that will support CRLs. On Dominic Bayer's site, leastprivilege.com, he has a bunch of instructions on how to configure the Windows CA so it publishes a CRL to a website. So that CRL must be available for WCF to check it. And it's all reasonably simple. And once you've got it set out once, you can just go ahead and play to your heart's content, and everything acts like a real SSL certificate would, as opposed to self-signing. So, do we have any questions on that one? That one's kind of hard to demo, so I'm not going to, mainly because it would involve setting up multiple machines, and I'm sitting in my house, and I only have my laptop. Do you have any questions?
None so far.
None so far. They're all still asleep. It's so sweet. Okay, fair enough. We'll move on to the next one. Failure to restrict URI access. So I have a demo for this one. Oh, the excitement. Maybe you'll all start waking up when you see demos again. So we'll go back and go away from MVC now. And we're back into straightforward web forms just because it's easier to demonstrate these things in web forms. So failure to restrict URI access. Here we have an admin directory. Now, yes, I realize normally you're all going to remember to protect your admin directory with web.config. So what we'll do is we'll hit the perform administration action, and we'll find that we've deleted Gary Short, who is one of DevExpress's evangelists, if only it were that easy in real life. So that's fine, and we know that we've made a mistake because we don't have our web.config set up. So if I scroll back in, I'll go up to my web.config, and if I uncomment this, we would get bounced to our login page, hopefully. Yep, so that's fine. But let me uncomment it again, because I'm sure some of you, if not the vast majority of you, actually work with other people. And I would put the question to you, how many of you trust all of your coworkers? How many of you, are happy enough to rely on your coworkers to set up authentication and authorization configuration? Because it can be forgotten. I know I've done it myself, and it's been very embarrassing. So if I switch to the code, which is the code behind the website, I'm going to show you principal permissions. Now, principal permissions are part of code access security. That's been revamped in .NET 4, but principal permissions still exist. And you can see here I'm calling I'm demanding the permission. That means it needs to be fulfilled, all the parameters it has. And I have a parameter of role equals administrator. So what this attribute does is it protects this method that you can see it's being applied to. What will happen is anyone who is not an administrator will see a security error. Now, this security error is evaluated by the .NET framework itself, and the attribute is embedded in code, so you can't really get around it by forgetting. So if I click it here, I should get a yellow screen of death. Now, all of you, of course, will know that you should never ever show the yellow screen of death, but this is because I'm running against localhost. So we can see that we have our security exception failed. So even if someone has forgotten to set up the web.config, we are now actually demanding authorization rules within our code. So the principal permission can be applied to a method. It can be applied to an entire class. It can even be applied to an assembly. So this is quite nice if you have everything separated out into all the little layers like you should do. So you could put principal permissions on your business layer. So if the web developers have forgotten to set up the authorization, well, your business layer will then stop them. So you have this defense in depth concept starting to go. So you have your first line of defense is the web server and the authorization rules within the web server. Then on your business layer, you also have authorization rules, which in this case are demanded by the CAS permission. So does that make sense? Do we have any questions apart from someone feeling very, very sorry for Gary?
Well, the only question that's popped up is there any guide for security from Microsoft?
Ooh, that's a big question. There are a bunch that I'm aware of. So there are guides for hardening IIS. and the infrastructure. And then there's the SDL website is probably your first first and best stop-off point, which I believe, and if I get this wrong, I'm going to get so much grief. So let's just start up a browser because it'll be embarrassing otherwise. I believe it will be www.microsoft.com/is it SDL? Yes, Microsoft.com/SDL. So this covers the whole security development lifecycle. So after a few major security flaws, including Blaster, there was a memo sent around that basically we weren't concentrating on security enough. So basically what came out of this was the security development lifecycle, which is something that we all must go through if we're releasing public code, and that includes me. I had to go through it for anti-XSS. And it sets a bunch of standards for development practices. It covers threat modeling. It covers checklists of what is and isn't safe, including banned methods, functions. It provides some safe stuff for Visual C++ and so on and so forth. This is probably your best starting point as a developer. And it has a bunch of tools. It has a bunch of resources. It has a bunch of TFS templates if you're using TFS. It has some really, really funky things that you can run against your code. It has little mini fuzzers. It has threat surface analyzers and a bunch of other fun stuff. So that's basically your starting point as a developer. And then you can hop off from there. If you're an IT pro, there are a bunch of hardening guides on TechNet somewhere, but I can't remember the URL offhand. So hopefully that answers whoever answered that question. Does anyone else have? Oh, right. Okay, I can scroll up now. Well, that's cool. I should increase the question size because it's kind of small right now. Okay, can principal permission be applied to more than one role? Yes, it can. In the roles, basically just put them in as a comma delimited list. And in fact, you can use principal permissions to go to individual users, but we really don't ever want to go down that route because role-based security is where it's at rather than listing individual users, because individual users may leave and roles are an awful lot easier to manage. Then we have, what does URI stand for? Uniform Resource Identifier. So a URL is a type of URI. Hopefully that makes sense. So I've answered all the questions. Hurrah! So we'll skip on to the next one after, hopefully undeleting Gary, just to make Sarah feel happier. So one other thing I ought to say is security by obscurity is useless. It's all very well putting your administrative functions in a directory name that is some random generated GUID, but at some point that's going to leak, whether someone gets a hold of a browser history or whatever. You should be restricting everything via ASP.NET via configuration and no rolling your own. The integrated pipeline, which comes in IIS 7, will restrict access to absolutely everything, which IIS 6 didn't do. So in 7, you'll be protecting JPEGs, PNGs, PDFs, any sort of document underneath your web root. In IIS 6, you had to do all sorts of jiggery-pokery with the ISAPI mapping to set that up, and that had scalability issues. If you're still using IIS 6, it's probably a good time to start pestering your boss to upgrade you. And like I say, you use the principal permission to add defense in depth and to protect yourself. And IIS 7 sort of replaces the file ACLs that you had to set up in IIS 6 with a web.config based authorization list, which is by far one of the best reasons to upgrade to IIS 7 because it's in your web.config, so you can copy it from server to server. It makes things incredibly easy. And at 7, I should be doing this in some sort of, big trendy countdown that looks like a pop show where I have some spangly wig on my head, but we'll pass. Insecure cryptographic storage. So cryptography is an enormous subject. We can sort of do some quick demos. I'm not going to dwell on them too much because, well, the math behind it is ridiculous. So hopefully by now you'll know that you should not be storing raw passwords in your database. We've seen that happen all too often. Gawker, a bunch of rather interesting security sites have all got done by this. So you should be hashing your passwords, and what hashing does is it will take a plain text and it will produce a fixed value out of it. If you want to upset anyone in security, you should say that hashing is encryption, because then you'll watch them go bright red and steam come out of their ears, because it's not. It's a cryptographic technique, but it's most certainly not encryption. So hashing by itself is not enough, because what you will find these days is there are pre-computed hash dictionaries for all the hash algorithms that are out there. So what someone can then do is they can look at the hash if they've compromised your database, compare it against the dictionary entries, and lo and behold, they have the password. So what you need to do is you need to apply a salt value, and a salt value is a random value. It doesn't necessarily have to be random, but it should be, or something that's unique to that individual user. You append or prepend that to the password, and then you generate the hash out of everything. So what tends to happen then is you're not going to have a pre-computed dictionary that has every single salt in it, because hashes take a little while to compute. And then when you're comparing things, you just recalculate the hash and compare against each other. Now, one thing I should say is when you are doing hash comparisons, it's often tempting when you're doing the byte by byte comparison, the first one that fails, to exit out. You shouldn't. You should continue on, even though there's been a failure, all the way down the full length of your hash, and then return false. If you exit out early, you are vulnerable to what's called a timing attack. So people can start working out which part of the hash is valid, and that can be used in conjunction with rainbow tables to start trying to zero in. We have symmetric encryption, and I'm going to just shove some things in here. And we have encryption of password, and I can decrypt it back again, and it works. Symmetric encryption is where you know what the password is. So if you're having two systems talking to each other, each machine must know what the password is. And then you can use a salt, like we have with hashing, and an initialization vector. So the salt and the initialization vector are things that feed into the algorithm that help it to encrypt. Now, symmetric encryption is very, very fast, but more importantly, symmetric encryption can encrypt an awful lot of data, because the opposite of symmetric encryption is asymmetric encryption. Now, asymmetric encryption has an awful lot more properties. Don't ask me what all of these are, I just know they exist. So what I have done is I have generated a random asymmetric key, and this is a cryptographically secure key. If you want to generate random numbers for use in cryptography, there is a specialist class for it within the system.cryptography library. Please don't use random from the .NET framework. It's nowhere near secure enough. So again, I can just type in bits and bobs and click on encrypt, and I get something that's slightly bigger, and I click on decrypt and it comes back. Now, asymmetric encryption generally is used when two machines talk to each other, because what happens is you have the concept of a public and a private key. So the encryption key gets split up into 2 bits, and anyone that has the public key can encrypt, but only the person with the private key can decrypt. So you can hand your public key out to people left, right, and center, and they'll be able to encrypt and send things to you, but only you will be able to see what's inside. So hopefully that makes sense. I know it's not the world's most exciting topic, but it is important. People get this wrong an awful lot. Oops, wrong one. So, like I say, symmetric is where two systems share a key, so this should be used for basically communication within your own internal network, or storing data in SQL Server and encrypting it where the key is held elsewhere. Asymmetric is this concept of public-private keys. Certificates can be used for this, and when certificates are used for this, it's generally the most popular way of doing it. Then what tends to happen is that people will encrypt against your public key of your certificate, and they will sign using their own key. So when they do this signing, you now know where this encrypted data has come from. There are safe algorithms that you should be using. For hashing these days, it's SHA-256. For symmetric, it's AES. For asymmetric, it's that one. As the speed of computers move on, old algorithms get retired. So, for example, MD5 has a few problems with it these days, so you shouldn't be hashing with MD5. When you do start doing this stuff, I would advise that you have a field in your database or whatever your data store is that keeps the encryption algorithm that is being used. So then when an encryption algorithm gets retired, you can update your code so it uses the latest and greatest one, but you'll know what all the previous data was encrypted with, so you'll still be able to decrypt. Does that make sense? Yep, we're all RSA. You need I need more than RSA question mark, because I'm unsure what the question is referring to. So RSA generally is an asymmetric algorithm. I mean, algorithm choice is kind of a personal thing, but there's a FIPS standard by the US government, which will say what the latest and greatest algorithms that they consider safe are, and those are the ones that you should be using. And RSA is one of the asymmetric algorithms, but because I've got RSA question mark, I'm kind of Please say that again about storing encryption algorithm with the data. Are you saying to have a small text field that contains text? Yes, I am. So when you encrypt something, you would have a small text field that says the algorithm that you've used, and then you can look it up when you retrieve your data and know which algorithm you're supposed to use to decrypt. And then when you get a new one in, well, the new algorithm then will go in all subsequent data, so you don't have to worry so much about backwards compatibility because you've already coded it in. Does that make sense? Hopefully. So use symmetric when all the systems are under your control. There's no need to identify who did the encryption. Use asymmetric when you're accepting from external systems. You can tell who has encrypted and signed if you start using X509 certificates. And the other thing about asymmetric encryption is it's all in memory. So no large plain text. I've lost a T somewhere. And what happens is actually the two get combined for speed and security. So when you start up an HTTPS session, what happens is we'll use asymmetric to start off with, because you can see the public key in the HTTPS certificate, and part of that initial handshake generates a symmetric algorithm, and that is securely transported down to the client. And the symmetric algorithm, because it's faster and you can do lots and large pieces of data, that's used for the rest of the conversation. So that's basically it. Don't reuse your keys. You can treat keys as you would tissues. You know, you've used it once, you need to throw them away. Don't reuse them. Store your keys outside of your main database, preferably in another machine, in another country, in another data center, on another planet. It's very hard to get secure key storage right, and people make a lot of money selling solutions around that. You use crypt gen random, which is the class for random numbers, and you shouldn't be reusing your salts. You shouldn't be reusing your initialization vectors. And there's I've lost a P as well, data protection API within Windows that can provide a secure key store, but it stores them on the local machine. So as soon as you get into a load balance scenario, it's no longer suitable. I've got another question from Sarah. In ASP.NET, does the data generated by the cryptographic library make use of the machine keys? No. The machine key is, well, actually, it depends. So the machine key is used when you are encrypting things like view state and the forms authentication token, but the rest of the time, no, it's not used. As soon as you start using system.cryptography yourself, you are free to use what you want as the key. So it doesn't touch machine key at all. So basically, when you're doing that sort of thing yourself, you shouldn't have any worries about load balanced clusters. If you're using certificates, obviously you need to publish the certificate to each machine within the cluster, but that's it. And isn't a salt required for decrypting data? Well, if you've used the salt for encrypting or for hashing, then yes, it is. You need to store the salt as well as the results of your cryptographic operation, and you can actually store the salt beside the results. It doesn't have to be kept as secure as the key. So hopefully that answers both of those. Next up in 6, we have security misconfiguration. There is no demo for this, because basically what this boils down to is you should be patching. You should be patching pretty much as soon as you are happy that the patches will not break your application. And this also applies to things other than IIS and ASP.NET. If you're running a bulletin board in your site, you should be subscribed to their security alert mailing list, and as soon as something new comes out, you should be patching that too. IIS 7 introduced the concept of app pool isolation. It used to be you'd have to configure app pools with their own identities. And that kind of became hard to manage. So what IIS 7 does, and you can read about the details there, is it actually uses a standard app pool identity, but each app pool gets its own sub-identity within that. And you can use that sub-identity to actually apply access control lists to directories and so on and so forth. So the app pools, even though they're running under the same core identity, they're isolated from each other so they can't talk. You also have URL scan, which you can plug into IIS that will look for suspicious requests coming in and out. Oh no, sorry, just in. And will stop them based on patterns. You have the security runtime engine, which is mine, and is part of the web protection library, which Anti-XSS lives in. It's still kind of in CTP because I've had no time to finish it off, which is kind of embarrassing. I can only apologize for that. But what that does, it will wrap your requests and your responses and give you inspection points as requests and responses go through the pipeline. You can download it from wpl.coplex.com and compile it up and have a bit of fun. There's an example in there for that will stop any web page that has a credit card in it. So, for example, if one of your developers has made a mistake and they're showing credit cards in the clear, the WPL module for that would throw an exception. The other thing to do is obviously you disable any unused modules, accounts, etc. You don't install everything. Windows 2008 is very good at this and it makes you enable individual bits. But when you enable ASP.NET, there are a bunch of modules that are still around. These are in there by default, including passport authentication, which no one uses anymore. So this is an HTTP modules section from your machine.config. You can actually remove them on a website by website basis. So here I've removed passport authentication. I've also removed profiling and anonymous identification. There are a bunch of them that you can remove, but you will find that if you remove certain ones, other modules will break. For example, Forms Auth needs the caching module, and I've not seen documentation for this. So be very careful when you start removing things. Check that everything still works, and I would just suggest removing them one by one, but always remove passport authentication. Cross-site request forgery. This was #1 in the last one, and it's great fun. So basically what this does is allows people to submit form requests to your website. So if I go here, I have a very boring bank site. I click transfer, I've got money transferred. Back we go. So I can view the source for this. It's nothing particularly exciting. If I save the source, oops. I'm going to save it onto my local machine, just as an HTML file. And then I can bring this up in Notepad. Except Notepad's gone over there. Come back, nice. And I can change the action URL. Let's make sure I get it right. Whee! So imagine that I'm an attacker and I've taken a copy of your form. I believe I have to get rid of that nonsense too. And I've hosted this form on my website now. So if I double click this, you will see that this time it's coming from my desktop. So I click on transfer. Oops, I removed too much. I've clicked on transfer from my desktop and you will see that the money transferred has happened. So if we imagine my desktop is in fact badsite.org and one of your users has come to badsite.org and click transfer, which they wouldn't do, admittedly, but we'll go into a more realistic scenario in a minute. It's called back to your website and perform the action. So you'll say none of my users are stupid enough to see a form that's on something called badsite.org and hit submit. And that's very probably true. However, now picture all these fields as hidden fields inside a form that gets submitted via JavaScript in the background. It's perfectly possible. So now a user has gone to badsite.org and it's done the money transfer operation without the user actually seeing anything. So can we see why this is a problem? Hopefully. So there are a couple of ways to get around this. If I go back to Mr. Slides, in web forms, you can use viewState, and there's a property called the viewState user key, and that will allow you to set a unique value per user. You need to set this within page initialization, and what will happen is then the viewState is locked to a current user. So if an attacker comes, saves it off, and then tries to submit it on behalf of another user, the viewState user key is different, so the request will get rejected. You can also use a more straightforward CSRF token if you don't like using viewState, and this module was basically an example out of my book, which we'll pimp at the end, obviously, but you can download the source code and play with that. For MVC, there's an HTML anti-forgery token that you just embed this little part in your form, and then you decorate your action method with the validate anti-forgery token attribute, and you encourage your users to log out. The reason that this works is that even when a user is on another site, they're still logged in yours. And so every request that goes to your site will take the authentication cookie that you've dropped with it, even if that request has come from another site. So whilst bad site can't see the authentication cookie, it can make use of it because as soon as it submits a form to your site, that request is going to your site and the browser will send the authentication cookie to it. So hopefully that makes sense. Does anyone have any questions? No. Cool.
Hey Barry, it's Mehul.
Oh,
so this anti-forgery token.
Yes.
So is that only on the post method?
Yes. So, all right, you should only be doing things on the post method. You should never be changing state on the get method at all. That breaks the HTTP specification, so just don't do that. You should only be doing things on post. Does that answer your question?
It does. Just so, but I'm not clear as to why you're saying, hashing is exactly like encryption.
Okay, I'm going to take that offline with Mehul. I'm going to get a hammer and I'm going to educate him on why hashing is not encryption. We do have a sensible question. The token remains useless if the app is also vulnerable to XSS. Correct. That depends, Felipe. If you're dropping so we have part of the token gets embedded in the form, which is generally a random number, and part of the token gets dropped in a cookie, and the two things are compared. Now, when you create cookies, you can mark a cookie as HTTP only. And what that will do is, in the vast majority of browsers, that will only allow the cookie to be accessed as part of an HTTP request and a response. It will not allow the cookie to be accessed via script. So even if you have a cross-site scripting vulnerability where you can inject JavaScript and access the cookies, because you've marked that cookie as HTTP only, the browser will not allow access to that cookie unless it's a really early version of Safari, because the standard security methods for cookies weren't good enough for Apple, and they ignored that one for a long time. Okay, hopefully that makes sense. What is the name of the Windows module that stores encryption keys? It's the Data Protection API. So it's either DAPI or DP API. I think it's DAPI because I used to call it DPAPI, and then I got laughed at. So Data Protection API, and you can access that from within the .NET framework. There are managed classes for it.
Hey Barry, so if you're using any type of authentication, is that still necessary to lock the view state?
Yes, it is. Or put a to put the token in, because authentication is not enough. The reason that this works is when you authenticate, a cookie gets dropped in your machine, and the cookie basically says, "Hi, I'm Mehul," and it will get sent with every request to your website, so the website can re-authenticate you without having to make you log in with every single request. That just wouldn't work. So then when a bad person sends a form submit to your website, the browser goes, "Oh, this is going to DevExpress.com. Hey, I have a cookie for DevExpress.com, this authentication cookie, so I'm going to send it with this form submission." So the cookie goes with it. And so that you're still authenticated to DevExpress.com because you have an authentication cookie, and therefore the form action will work. So this is a good reason why you should be encouraging your users to log out of sensitive websites, because as soon as you log out, this authentication cookie or whatever authentication bits and pieces you're using goes away.
Any advice you have for timing out of those sessions?
Well, the forms authentication modules include timeout by default. It's very hard to give a general guideline because it depends on your application. So if you're administering your blog, you probably want to time that out after about 15 or 20 minutes. If you're commenting on a blog and all the cookie stores is a username or a person's name and their website, then that doesn't matter. It is very, very applications specific, to be perfectly frank, and there's no general advice here.
Gotcha. Thanks.
Okay, so number 4, especially as we only have 10 minutes left, we shall dash through these now, is insecure direct object reference. And we'll go back to funky demos. So what we have here is a pseudo email. I choose the email because a couple of years ago, the Doctors Board in the UK had this very vulnerability. And what they did was they sent emails out to potential doctors about their placement within hospitals. And this included reasonably sensitive information like your exam results plus the profile of the doctor, which included things like their religion, their address, date of birth, sexual preference, a bunch of other stuff. And one doctor looked at the URL and he saw that there was a message ID at the top. And he thought, what will happen if I add 1 onto the message ID? So if I add 1, we can see that I've now got another message, this time to Seth. And it says that Seth failed his exam and he should try drinking less. So if I go to 3, it should eventually wake up. And we're picking on Gary again and saying that baldness is not an excuse for extra marks. So this guy went up and down, and he could see all the potential doctor's placements. And obviously he was a bit upset by this. And it made the papers. The doctor's board accused him of hacking by adding 1. And there's a big brouhaha about it. So this is basically not good, and this is not what you want to do, very obviously. So you should be using indirect object references. Don't use your primary key in a database as a parameter in a URL. Start generating GUIDs, and from that GUID, look up the actual object reference and then bring everything back. And you should always be checking access permissions, which is something that this UK doctor system did not do. So it knew who the user was, but it didn't check that the message that it was about to display was for that user. So you should be checking what you're about to display belongs to the user in question. And if it doesn't, you shouldn't be displaying it. And as an aside, for MVC, just for fun, because you have this automatic binding stuff, don't let any of the automatic binding happen against your ID field. So you should be applying bind exclude to your model. If you check access permissions, do you really need indirect object references and GUIDs as well? Kind of. It depends on your data. So for example, if you had order ID equals 1, 2, 3, 4, 5, yada, 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 how sensitive is the maximum number of orders that your company has had? That's something that may be of interest to your competitors. So in that case, you should really be using GUIDs, even if you are checking access permissions. For blog comments, no, not so much. It's one of those things that's very application dependent. But it doesn't cost that much more in terms of processing time for this indirect object reference. So as a matter of practice, I do it by default. And then, if suddenly I really think about it and it doesn't matter that much, then I can turn it off and go back to using a direct object reference that is secure. So hopefully that makes sense. I've got a question. If the primary key in the database is already a GUID, should it not be exposed, assuming correct permissions are in place? You're making a lot of database admins cry with that, because they'll say that the primary key in a database should never be a GUID because clustered indexes just go insane at that point. Again, it basically depends. If it's a GUID, you don't have this, I can count the number of open orders. So it's not so bad as long as you have the access permission in place. But like I say, you're going to make your database administrator cry. Broken authentication in sessions. Yeah, you know what? This basically boils down to don't roll your own. Use forms authentication. Use the ASP.NET sessions. Don't start rolling your own where suddenly you see a session ID in the URL. It's like encryption. Whilst it may seem like a good idea to roll your own to begin with because you think you're wonderfully clever, it generally turns out that you're not. If you want to validate every session to make sure that it's coming from the same place, I've seen people do this by looking at the IP. And if 2 sessions come from a different IP with the same session ID, they go, "Ooh, that's a hack." Unfortunately, it's not. For example, Microsoft has rather a large number of outgoing HTTP proxies that you will get routed to on a random basis. So the IP address may well be valid and changing on every request. So probably the only thing that's fixed that you can look at is the browser string, because that's not going to change from request to request. Someone said, can we use encryption in the query string to solve direct object access? Yes, I guess you could, but that will introduce a processing overhead that's probably greater than just using indirect object reference, because encryption can be a little bit slow and heavy. Plus, you shouldn't be using the same key, so you should have a different key per session, and then managing all that becomes a bit of a nightmare, to be perfectly frank. So we'll skip on, because we've got 5 minutes left. Cross-site scripting, which has already been brought up, thank you very much, by someone. So we'll quickly demo this. You've probably mostly seen this before. Enter search criteria. I'm going to do script hello world. And lo and behold, because I'm not encoding properly, I have JavaScript running. Hello world, not that impressive. But however, you've got to remember that JavaScript can access your document, and then you have document.cookies. So you can actually start accessing cookies. With JavaScript, you can affect the page itself, so you can change text. So you could insert an image tag, which has a location on badsite.org, where it points to a 1x1 transparent GIF. And as part of that URL location, you could then append document.cookies. And if you haven't protected your cookies with HTTP only, they'll all go with it. This is another reason to use ASP.NET session and ASP.NET form authentication, because they're all marked correctly with HTTP only, so they'll never travel. Now you may think I'm going to be clever. I'm going to look for the word JavaScript, and that's absolutely fine until you realize that people can start mixing it up with cases. So you're going to do a case-insensitive search, and then you have this. This third one is exactly the same as the top one, and you can keep doing this. You can keep encoding again and again and again, and filtering in this way is not the right way to do it. Basically, you should be treating all your input as evil. You should be working from whitelists for filtering, not from blacklists. You should be storing unencoded data in your database and re-encoding when you come out. You should be using HTTP-only cookies. You should be using anti-XSS because it's mine and I'm lovely. And if you want to look at ways to get around XSS filters, this last URL is scary. I suppose I should really show you how you're supposed to fix this, because that would be useful. So we go to cross-site request forgery, and basically, oh no, that's the wrong one. We're in XSS, silly me. Instead of directly echoing input as output, we encode it using HTML encode. Or if it's going into an HTML attribute encode. XML encode, XML attribute encode. There are an awful lot of encoding algorithms. The anti-XSS library adds an awful lot of them. So you should be choosing the right one for where you're outputting to, because if you choose the wrong one, you may be vulnerable. Simple as that. So we have 1 minute left. Injection flaws. I'm sure we've probably all seen SQL injection demos, so I'm not going to show them now. But it's interesting that this is back up to number 1. It was number 2 3 years ago, but it's now back up to number 1 again. So even though you've probably all seen the demos, people are still making things that are vulnerable. So for SQL, we should be using SQL parameters. We should be using SQL's permissions to remove direct access to the tables. If we have a store procedure that, for example, is a search where we're actually building up the command within a store procedure and then using spexec, we should be using parameters in those too. If you're using XPath, you should be using XSLT context to add parameters, or you can use the MVP XML library, which allows pretty much parameters for XPath queries like we have for SQL in the .NET framework. I've been asked if link is vulnerable to SQL injection. Generally, no, but there is an execute function in link to SQL, which executes raw SQL. So that one may be vulnerable depending on how you build your SQL string that you pass to it. So this is how, basically everyone now is using parameters, hopefully, but people forget to use it within a store procedure. So this is how you put parameters within a store procedure, where you end up calling exec because you've had to build a query string dynamically. So this is what you should be doing within your store procedures, and a lot of the injection stuff I see now is coming from within a store procedure itself that's calling exec. So changes from 2007. We no longer, malicious file execution is no longer in the top 10 and was mostly PHP. Information leakage and improper error handling. Well, we've seen the yellow screen of death, and we all know not to have that. That's a lot of where that was coming from. We've now got security misconfiguration and unvalidated redirects and forwards being added in. And here we have the latest top 10 in all its glory. I should have the mandatory book pimping slide because people will be upset if I don't, or at least my publisher will be upset if I don't. And then finally, have we any more questions apart from Mahul trying to make me cry? No, there's silence.
We don't have any questions just yet. It's just silence, crickets. Yes.
We've got yes.
I'm assuming that means there's a question coming.
Hey Barry,
yes.
So while they're writing up the questions, I'll ask you. I'm surprised
Please
SQL
don't.
injection is number one.
So am I.
I'm gonna ask you a loaded question. So do you feel
yes,
are store procedures safer than straight SQL? I mean, the trend nowadays seems to be away from store procedures. But since you can pass in, well, I don't want to say trend, but I just see a lot of.
So you can parameterize raw SQL as well, and any good ORM worth its salt will be doing so. So you notice how carefully I say that. I am not going to recommend an ORM in any way, shape, or form. So
take a stand, man. Come on.
It's possible. Yeah, the NAU framework does it correctly. So it's possible to, raw SQL is not so bad, but store procedures give you a little bit more control. For example, I don't like the idea of developers running riot over a database and having select and insert permissions on the raw tables. That doesn't particularly make sense to me. But then again, I know a bunch of SQL MVPs, and some of them are bigger than I am. So, it's fine. It depends how you want to treat your SQL database. If you're just treating it as an object store, as somewhere to store data, and all your logic is sitting within your application, then yeah, I mean, let an ORM take care of it, or if you must write it yourself, you can actually just provide parameters within your raw SQL itself and then attach them as you would to a store procedure, and that's absolutely fine.
Gotcha. And so if you're using something light like link as, maybe you shouldn't use link as an ORM, but let's say you're using it that way.
Yes.
You've already said that link parameter makes those parameters already for you, right? Whenever
it does, yes.
Awesome.
As does the entity framework, and I'm sure your ORM does too.
Yes, XPO does as well.
Okay, see, how nice am I? You'll notice that I actually disabled ReSharper within Visual Studio because I didn't think that would be politically correct.
Yeah, because it's just, it's not your favorite anyways, right?
You'll leave that alone.
This just got really awkward.
Yeah, so there are 2 more questions that we should address, and then I believe we're over the hour. So is there a better way to send session ID to the server apart from putting it in the URL? So you can put it in the URL if you've got HTTPS on. That's always good. That will protect the URL. If you've got HTTP, then it should be going via cookies. I worry when I see sessions in URLs that are over straightforward HTTP. That's a bad thing. So is there a better way? Yeah, shove it in a cookie. But of course, if you have a sniffer that's running in your network, they'll be able to sniff the cookie too. So the only way around that is to run over HTTPS. Firesheep was a great example of how to mess with Facebook because they weren't running over HTTPS. Are there any further references from view state user key, CSRF, and validate anti-forgery token? Sure, they're in my book. So view state user key is and the validate anti-forgery token are both covered in MSDN because they're part of the standard .NET framework, and I'm sure that Phil Hack and John Galloway have written about the MVC bits. I can't remember who wrote about view state user key, but a quick bing. Oh, a bing, look at me, will find you more bits and pieces. The anti-CSRF thing is actually an example from my book, and it shows how you can intercept requests and responses, and that's on Codeplex. And there's some documentation around it on Codeplex. There probably should be more, but because it's more of an example than anything else, I haven't spent the time to do it. Do I know of any advanced books or resources? That's kind of hard to say. Everyone's concept of what is advanced differs. And in fact, you know what, the advanced stuff moves so quickly, I'm not convinced books are that useful. So there are a bunch of blogs out there. Start with the OWASP stuff, and then start following links down to other people's blogs, and you'll start finding people that you consider useful. But it's all much of a personal opinion, so I can't really give a solid answer for that. And finally, I am a developer working in an MS architecture, but the servers are handled by other people. Oh, IT admins. I shouldn't say that considering I sit in Microsoft IT. What tools or methods can I use to make sure they follow proper security configuration? So Microsoft publishes a bunch of IIS hardening guides, as I believe does one of the, I think the National Security Agency in the US also produce OS guides. There are a bunch of best practice tools out there, including WACA, which stands for Web. Oh boy, that's embarrassing because the guy that writes it is 2 doors away. I can't remember what it stands for, but it looks at configuration files and basically makes sure that the IIS configuration is set up correctly. But of course, you've then got to convince your IT admins to run these things. Oh, there's one more. When I do security testing my software, I stumble onto complicated attempts. I don't want to remember testing for. I want to be able to perform real-life queries, any reference. No. Because real-life attack queries, well, they depend. The ones that are going to work depend on your application. So you get a bunch of automated scanning tools. The one that our guys use a lot is Burp Suite and Burp Suite Pro. They also use a few others whose names I can't remember. I only remember Burp Suite because it makes me giggle every time I hear it. So this is neither a recommendation for Burp Suite or not compared to others. It's just the one that I remember that we use internally. Can we have your slides? Yes. I'll make sure to pass those on. And that's pretty much it. I assume. I'm sorry, I've run over by 8 minutes. I am going to blame Mahul for that with his interruptions.
Absolutely.
And with that, I shall say goodbye and actually get into work now and do some work.
Awesome. Thank you so much, Barry, for being here.
Oh, you're welcome.
All right, everybody, just to wrap up, we have several webinars still coming up this week. You can register at devexpress.com/webinars. Tomorrow at 1 p.m. Pacific Standard Time, Advanced Text Commands in CodeRush with Mark Miller and Rory Becker. Wednesday, March 16th at 11 a.m., Reporting with Charts and Pivot Grid with our reporting evangelist, Seth Juarez. And I think Barry did a few slides on him and his drinking problem earlier. And finally, Friday, Pivot Grid UI features with analytics evangelist Woody Pewitt. You'll see some of the advanced features of the Pivot Grid for data visualization. So again, that's devexpress.com/webinars. And if you missed anything from this webinar or you want to review it later, we do post them on our DevExpress channel at tv.devexpress.com. So again, thank you so much to Barry for being here. Thank you all for joining us, and thank you for choosing DevExpress.